Well, thanks for joining everyone and happy first day of February. My name is Pam Thomas. I'm the Chief of Staff here at Foursquare. Today, we're excited to bring together leading experts, Vin and Kumar, to share their top predictions for 2023 as the world's post-pandemic normal materializes. In the next hour, we'll be discussing why advancements in data visualization and clean room technology are disrupting how companies approach decision-making, why companies will be leaning more towards low-code, no-code platforms and tools that can be easily understood by their entire enterprise, and how incorporating high-quality location data into existing graph databases will bolster strategic planning across industries. Vin and Kumar, I would like each of you to spend some time introducing yourself to our audience today. Kumar?
Thanks, Pam. Hi, folks. My name is Kumar Chellapilla. I'm a general manager at the AWS Machine Learning and AI Services Group. I manage services under the SageMaker umbrella. Most recently, we launched SageMaker Geospatial, which is a set of purpose-built APIs for working with geospatial data and SageMaker. Previously, we also launched SageMaker Ground Truth for data annotation and generating label data sets or mapping data sets using SageMaker. In addition to SageMaker, I also own a few other services, specifically machine learning and AI services for developers and security engineers, such as Code Guru and DevOps Guru, and machine learning services for defense and intelligence communities. Before AWS, I worked at a few startups in the Bay Area, Lyft and Uber for ride sharing, Twitter and LinkedIn for social media. And before that, I worked for a few years at Bing Search and Microsoft Research. Super excited to be here to talk about location intelligence and the upcoming trends.
Thanks, Kumar. My name is Vin Sharma. I'm a VP of Engineering at Foursquare. My team develops geospatial tools and data sets for organizations that want to build location-based apps or make business-critical decisions informed by location data. So we build dashboards for business analysts, SDKs for developers, a mapping and visualization studio for data scientists, as well as the engines that collect and process raw location data into refined, curated, corrected data products. And so our tools are built on AWS, and our data sets are available from the Amazon Data Exchange. But beyond that, we have an even deeper collaboration with AWS, specifically with Kumar's team. AWS uses Foursquare Studio to power the geospatial visualization capability in Amazon SageMaker that Kumar just mentioned. And on a personal level, I've had the pleasure of working with Kumar as part of the same team in the AWS AI organization, where I worked for 5 years before joining Foursquare. So back to you, Pam.
Awesome. Thanks, Vin. Thanks, Kumar. Before we kind of dig into the trends, perhaps we can set the stage by talking a bit about the new challenges businesses are facing in today's climate. What are you hearing from customers, partners, businesses? Vin?
Yeah, so maybe we step back a little bit. There is definitely a lot of concern today about the macroeconomic environment with talk of recession, particularly for the tech industry. But, if I were to step back a little bit and look at the bigger picture, I'm old enough to remember these recessions coming and going several times over the past few decades. But we live, the one thing that doesn't change is that we live somewhat in a larger, macro technological environment. And it's like a data field, an electromagnetic field of data that continues to grow around us, because the amount of data that people and things that are connected to a global network have been generating for the past 20 years continues to explode. And the demand for that data continues to grow. So even as we consume or produce and consume more data, the appetite for that data by individuals in individuals and organizations continues to increase. So one of the things that I think is going to remain the same is the need to make sense of all of this data. Now, the tools, the techniques, the platforms that we use to make sense of the data are changing, will change. And Kumar and I will speak to the machine learning capabilities that power a lot of those new tools. But fundamentally, the need to make sense of data is going to remain the same. And I think it's going to keep pushing the tech industry forward.
Awesome. Thanks, Vin. Kumar, anything that you're hearing in your world?
Yeah, I think what Vince mentioned is very true, right? Companies and applications are becoming what I would call data rich. We've seen the developments. I think of these technology transformations or developments as running in cycles. And if you remember the pre-web era, there was the movement to the internet, which came out maybe in the late 90s, early 2000s. And then if you look at the 10 years after that, there were mobile technologies. Everything had to have a mobile app. And these transformative technologies have already produced a lot of data. And the rate at which data is growing, both about the users, the world, the earth over time has really transformed companies into becoming very data rich. Now, they're also inundated. And so what I see from the machine learning side is that machine learning is no longer a niche. I think it's reached a point where companies are looking to industrialize machine learning. And what I mean by that is every application wants to understand the data that it has, the users that it has, in a way so that it can come across as being smart. You don't want just a mobile application, you want an application that is smart. And mobility means that you have a lot of location aspects to it. Right? That's one trend I'm seeing, which I think we're in the infancy, but in the upcoming decade, it'll become big. The other one I would say is companies and customers are also expecting a lot more greener technologies. Climate change is something that's top of mind for a lot of tech consumers, especially the auto industry, which is moving from combustion engines to electric vehicles and so on. Everybody wants to think about sustainable technologies, zero carbon technologies, and understanding the world in real time and adapting to change as quickly is becoming the norm. Right? Last but not least, I do agree, if you look at the short term, there are quite a few headwinds in the technology space. The last 3 years of COVID have sort of given, to some degree, a much more aggressive estimates for how certain transformations, like going completely virtual and doing everything remote, have been overinvested in. And so as you see that correction come, we're facing a few headwinds there. But top of mind for businesses is efficiency and productivity. This has always been the case. But if you look at how quickly companies have grown in 2023, more than anywhere else, they want machine learning engineers, software engineers to be more effective, more productive, and more efficient, and do more with less. I think ML and AI technologies and location technologies will actually help people bring that forward and accelerate in 2023.
Awesome, awesome. Well, what I'd like to do now is just let's dive into the first trend, going visual with data. Then this question is for you. What new advancements should we expect to see in this area in 2023?
So before I dive into 2023, I actually want to go 500 million years back. And I know it's a bit of a twist on the question, but if you imagine the way that we make sense of the world as through our senses, the one sense that we use the most, many of us, is the visual sense. It's because 500 million years ago, there were photoreceptor cells that, essentially generated a whole brain behind them to process the signals that were coming in from the real world. And we've acquired that. Our brains are finely tuned to this. And so when you look at a picture, it conveys so much information, 1,000 words as the story goes, because we're evolutionarily programmed to extract that signal from visual data. So when you think of visualization, don't just think in terms of pretty pictures of charts and maps and diagrams. It's actually the most efficient way of transferring and extracting information out of large quantities of data and delivering it into our brains and to our understanding and to make sense of it and do something with it. So for me, the power of visualization tools today comes not just from representing the data, but actually being able to explore the data through that representation. So you want tools that let data scientists and data developers and data analysts figure out patterns and relationships in the data through that visual representation. So you want visual exploration, but with visual exploration, you start to look for patterns and they explain things. So you end up with visual explanations that help tell a story, not just of how things have worked, but maybe something deeper than that. And as we keep going forward with this, one of the things that my team is really excited about is taking this new developments in machine learning models and capabilities for forecasting and prediction and building it into that visual analytics studio toolkit, if you will, so that the story we tell isn't just about what has already happened, but what will happen, or perhaps what is likely to happen, and multiple potential scenarios of things that could happen, and to help decision makers make better decisions, right? So they could start to look at location data and explore it through this visual environment and start to build explanations about the movement of people, particularly as Kumar mentioned, now that the pandemic has kind of in some ways reconfigured our patterns of work and play and life. We aren't just fully virtual or fully remote or, fully back at work physically either. So there's a change in how we work and we play and interact. And those patterns become evident through this visual representation and the visual explanations. But most interestingly, if we start to then have decisions that help, organizations, drive their business and expand their business into new markets and new territories. If they want to place a new store at a particular street corner, how do they know that the demand, through foot traffic to that store is likely to sustain that business at that location instead of a different location in the same neighborhood or in a different neighborhood? And so these predictive capabilities, being able to do that through this visual interface, I think will get this information faster to businesses and to individuals, so much more than before. So 2023 to me is that turning point when visualization gets takes ownership of explanations and predictions and becomes a visual analytics capability more than a representation capability.
Thanks, Vin. And talking about capabilities, let's talk about our co-partnership with Amazon. So Foursquare recently partnered with Amazon to power geospatial data visualization in Amazon SageMaker. Kumar, can you tell us a bit more about the trend of data visualization more broadly and why geospatial visualization was an important component of the overall AWS Amazon strategy?
Definitely. I'm very excited about this collaboration, by the way. It's very innovative, and I think it's going to change how we'll empower machine learning and data scientists to work with location data. SageMaker is the flagship machine learning platform that AWS offers for customers who want to build machine learning systems or AI systems. SageMaker provides many components across the machine learning lifecycle, everything from data preparation, data labeling, to training, to inference, predictions, and debugging and pushing things with very little ease to production. As you look at the trends, SageMaker's just reached 5 years. It's pretty young, but it's transformative. But the key aspect that's changing in the last year or so is we want to empower more and more machine learning engineers and data scientists who may or may not actually be skilled in machine learning or even coding. And if you look at the low code, no code trends now, how do you empower the next 10x entrants into machine learning? They may or may not even be engineers to begin with. They may not want to take 2 years or 5 years, whatever it takes to learn a new language or become conversant with computers with respect to programming or developing. So I believe that low code and no code will be the path forward for that. And these are not new technologies, they're new ways of leveraging existing technologies, right? And so visualization is a key part of that. Like Vin mentioned, I mean, I'm also a big fan of how we evolved, and I think we're known for our brains. And I can tell you that visual senses are primarily, like, they account for almost 50% of the reasoning or insights that you generate with your brain. You can leverage a lot more of your brain when you have visual data in front of you versus other aspects, right? Now, how do you put that to work? How do you bring that native capability? A lot of it is intelligence. And to me, space and time are the two things that are novel. Like, a lot of machine learning today, machine learning systems, AI systems are able to understand the data. You know, you put some data in front of them to some degree. If it's content, you can classify content. You can make certain predictions. But if you want to generate insights and you want to have humans still continue to lead, we would want to make them visual. And there's no better field than geospatial. I think humans are not only visual, but they're spatial. A lot of our memory systems actually work with space and time, So people remember when something happened, people remember where something happened, not just what happened. And so I think as machine learning systems become more holistic and not just think about what's happening, but also where was it happening, when was it happening, it's going to become important to include location intelligence and geospatial data there. And visualization is the most intuitive way to put things that are related in space together in a way that humans can quickly derive insights. And it's an interaction, right? If you look at how machine learning helps decision makers, or machine learning helps product development, it is really interactive. In a space like location insights, where you have to bring the best information you have at hand for decision makers to make a decision, whether it's a product, whether it's an actual inference, or even to debug an issue or to react in real time to something that's unfolding in front of you. Visual inference and the collaboration between humans and machines using location visualization is super key. So I'm pretty excited about how in SageMaker now we use Foursquare's visualization engines, and the technology is also very modern. Unlike previous generations where visualization was mostly passive, here you can actually do the interactive loop from visualizing the input data in real time, working on a large cluster of GPUs in the back to bring back computation, and then within minutes sort of visualize the predictions from your machine learning models, make decisions, and then react to real world events that are unfolding in the world. Right? So the power that we're bringing to product developers, machine learning engineers, and decision makers is pretty compelling.
Awesome. And Kumar, you mentioned ML models and machine learning engineers taking advantage of data visualization. Another trend that's on the rise is broader advancements in AI ML, as evidenced by the launch of innovations like ChatGPT. Can you shed some light on why AI and ML are gaining so much momentum? And I'll send the question out to both of you to answer.
Maybe I'll start, and then Vin, you can join in. I think this technology is just a few months old, maybe a few quarters old. It's if you look at the machine learning or AI trend in the last 10 years, people have moved from specialized AI to some of them even believing that general AI is possible, and a lot of that is coming from what people would call foundation models or large language models. ChatGPT is the latest thing in the news, but if you look at DALL-E, if you look at content generation, that's becoming big. And sort of what Vin mentioned before is this data, the large amount of data that we're able to add and the amount of compute we're able to bring to these machine learning systems is what's helping build that. For me, for location and sort of when I think of foundation models for geospatial, I think there's a ton of value there. If you look at the Earth, Earth is a beautiful thing. I mean, but whether you're looking at really close for aerial imagery or far away, you call it the blue dot from far away. The nice thing about geospatial is that it is one of those things where the information that's contained about the Earth is much more tangible and closer to finite than, let's say, vision or language. The amount of input variety you can provide to like a face detector or even something that's reasoning about video or image content is way larger. Now, still geospatial can be seen as visual pixel imagery, but the surface of the Earth, you look at something like, I like Hawaii. So if you look at Maui, which is an island, after a few passes of the satellite, after you mapped out the shores, the roads, the hospitals, and the locations of interest, the point of interest, it doesn't change that often. Now, there may be clouds one day, there may be sunny the other day, but you do want to have things like maybe traffic and so on that are dynamic, but you have this power of being able to converge to something that's close to accurate. And so foundation models can take advantage of that. The fact that over time, you can integrate all this information over space and time, like certain satellite companies have 5-10 years of data across many of the popular parts of the world. And being able to bring all of that to a foundation model and then reason about it with new data that's coming in that day, that hour, or even that minute is pretty compelling. So while ChatGPT and DALL-E and these new image content generation and also language, natural language interfaces, conversational style have become very powerful, I'm super excited about some of the new stuff that's going to come to foundation models in geospatial.
So I have a slightly different take on this, and Pam, it's to your question of why this is suddenly so interesting and why sort of your, from your 15-year-old high school nephew to your taxi driver to your grandmother is suddenly interested in ChatGPT. And the reason for it is to kind of think of it as the way that AI, ML capabilities have evolved, particularly today, is that they've kind of gone from being back when Kumar and I were in grad school, primarily academic ventures where there was a lot of, it felt, to be honest, where it was like computational philosophy. It was philosophers thinking deep thoughts about what cognition in human beings could be if only we could materialize it in silicon, in software and programs, and express those programs the way that our rational thoughts work. And so that was a large part of it. We've since changed that, particularly with neural networks, into more of a perception-focused approach, right? The perception of objects in the visual field, object detection and image recognition and things like that, back to the visualization theme, but also things that we recognize shapes or speech in language and being able to do that. So that's kind of moved the field. And it's also meant that we've now flipped it not just to being able to recognize these inputs of vision and speech or images and speech, but also to generate them. And that's why everybody's high school homework looks a lot different today than it did 3 months ago. And I think one of the things that you should separate out is that idea that the interfaces with which we interact with systems that may be smart or may not, or certainly not smart in the same way that humans are smart, those interfaces are now a lot more natural feeling because we can talk, or we seem to be able to converse with these systems using natural language. One of my favorite jokes at parties is when people ask me how many languages I speak, I say I speak two, English and C++. And I said it was my favorite joke, not everybody else's. But the fundamental notion here is that we're now at a point where we can speak to computers without having to understand programming languages, and that's why it's now all of a sudden so much more democratized. So many more people can engage with systems, smart systems, and ask questions. So the query language has changed. And what I think is likely to happen this year is an interesting dynamic where tools, many of which Kumar builds in his team, to help with code completion, right? So programmers that want to be able to correct very quickly the code that they're writing or complete it, or even code generation where they express an intent and the system generates the code for them. If done well, done right, if that code, I think one of the things that we need to do is kind of build mechanisms to better trust these systems that generate this content. But let's say that we start to do that, but even then, the human, the programmer, the developer should be able to inspect the code that the system generated. And if they both agree, then you end up in some ways evolving both. Our understanding of code improves. We become better at writing code because the system's now generating and completing code the right way. And as that happens, I expect that you'll see more and more people become conversant with query languages like SQL. So paradoxically, while you would think that tools like ChatGPT and others would just make programmers irrelevant, on the contrary, what I expect to happen is that more and more people will become conversant with the ability to query databases and extract information from them. They'll use a combination of natural language or code that it generates, and we'll still need systems programmers. We'll still need machine learning developers. At the end of the day, a machine learning model is code. Somebody's got to be able to train that code and write it and develop it and test it and optimize it and build the systems that execute it. So I do think that what's very likely to happen is that we will see a massive explosion in the number of people that become conversant with queries. And with that, I think everybody has the opportunity in some sense to be a citizen data scientist. And so data science isn't just this, little private domain for specialized experts. It becomes accessible to business analysts and to executives and to CMOs, and they start to get more richer insights out of the data that they have at hand.
Vin, did you just assign me a new goal for 2023? Become
Yes.
Yeah, I also want to add one more point. I think to me, it's this. I think on the technology side, you can look at, okay, we've moved from deep neural nets that were sort of like input output, like a convolutional neural net that could do vision, to transformers now, which can do sequences. So people think of some of the modern stuff under transformers as being, you can input a sequence, an infinite sequence or a finite sequence, and then get a response back in sequence. And then the third part, which is sort of what's happening now, is once you make the AI interactive, and it's no longer just you give it an input, it'll give you an output, and you can actually have a conversation where neither the human nor the AI needs to have the answer correct the first time. And as you explore, I mean, the definition of insights is you do data exploration, and through the interaction, both the human can change the input to the machine. And so in the conversation, as systems like ChatGPT go back and forth, the AI can gradually correct its knowledge of the world and also its output or its insights about the world, and the humans can work backwards and forwards with the information that's being provided. I think that interaction will provide, first and foremost, a lot of efficiency and productivity to individuals. And that's sort of, even if you're skilled in the art, it's much easier. We're way more efficient when we're conversing. Like right now, I'm talking to an audience, or I'm talking to Vin, I'm talking to Pam. Way more efficient than having to use other media. The second one is also, you don't have to be an expert. There are people like a CFO needs to make a decision on something that's an AI-based system. Now, they may say, I need a data scientist to go do a bunch of work for me, but you could pretty much converse with an AI or work with the data scientist and an AI in conjunction, and then come to a decision, because you're interacting and you're getting the information you need, you're updating, and you're able to make a decision. So these types of interactions, that's what you do with a search engine. The reason search has been so powerful is that it has raw information, but it just serves it to you in such an unsummarized and non-intuitive way that you have to do many, many clicks and read articles in depth before you can get the gist. With AI being able to summarize, you're accelerating that. And you can iterate with it to get better. Now, the same thing will happen to machine learning systems that do insights. So if you are doing location intelligence, you're trying to decide, like Vin mentioned, where should you open your next site? Or if you're resolving something that's a natural disaster, you got to respond fast. How do you quickly get the information you have? It's going to be approximate, but it's important to move quickly and respond quickly versus 3 months later come back with, okay, this was what happened 3 months ago, which may be useful for deep insights and retrospective analysis. But a lot of the times when you have to respond in real time, it's important to be able to integrate large amounts of data. And a conversational setup will make it very easy for somebody at the front lines who's operating the forces that are going to go react to it. People may have to go help somebody, first responders, or you may have to make a decision that day or that week, and you just can't wait for a month for deep analysis to come back to you. I think I'm pretty excited about that. That conversation capability, that interactive capability with an AI, that's going to become very real.
Awesome. Thanks, Kumar. I'd like to shift gears a bit. The next trend that we're watching closely is graph technologies. Vin, perhaps you can tell us a bit more about what this entails. How does graph work? How will graph technology play a role in the geolocation space as a whole?
Okay. So by now you know that I'm going to take the long way home in answering that question. So let's go back to what Kumar said earlier, because I do want to touch on how the notions of ChatGPT then unpack into the knowledge graph, which is kind of really, really exciting. The heart of it is that if you kind of, as Kumar said, the whole conversational interfaces and chat bots is still a relatively recent phenomenon, and it is popular and it is very, very compelling, but we are in many ways in the honeymoon phase. And so as the wedding glow diminishes and we start to get into the practicalities of marriage. Most people that study this deeply will recognize that a lot of what's going on with the chatbots and with these new generative AI models is pattern recognition applied to pattern generation. So it's a little bit, reactive. It's a little bit, not as bad as a knee-jerk reaction, but it's like if this were a human body, this would be like the central nervous system responding almost autonomously to things that are happening in the real world. But what's missing and what's different from the way the chatbots like ChatGPT operate today and what we would expect a really smart system, an intelligent system to do, is that the representation of knowledge and reasoning on symbols and concepts and being able to do things like positionality or composition, being able to determine whether a yellow ball is inside or outside a green cube, and reason on counterfactuals and things that could have happened but didn't, and what would it do if it did, and so on and so forth. These kinds of operations require the representation of knowledge and a better understanding of how the world really works, and using that representation to then drive reasoning, right? So if you start with that idea that we need to be able to not just respond to patterns and generate them, but to reason with concepts, then that is what marks a true, in some sense, intelligent system. And as we get in that direction, how do you represent this knowledge? And some of the most compelling ways in which we as human beings represent knowledge is associate our memories and connect them, establish relationships with what we have seen, heard, tasted, touched, talked to. And all of these relationships are representable or can be represented as a network, as a social network, or as a graph. And broadly speaking, in computational terms, we think of it as nodes connected with links to other nodes. And a node could be a person, it could be a place, it could be, some kind of an object or a thing. But all of these could be various entities that are connected to other entities. And so one of the things that I'm excited about and our team is working on is being able to extract these entities from geospatial data and embed them in some higher dimensional space, kind of represent these much the same way as language models represent tokens or, sentence sub-elements or structure, subjects, verbs, objects, etc., as tokens that can then be combined and processed. We want to take geospatial data and create a knowledge representation of that geospatial data in terms of the people, the places that they have been to, the connections between the people, connections between the places, the relationships between these connections and these movement patterns, and express that as a knowledge graph. And on that knowledge graph, then we can start to reason. We can ask questions like the famous Kevin Bacon game about 6 degrees of separation between people, or 3 degrees of influence. People exercise because they see their friends exercising, but their friends are exercising because they're friends, and so on and so forth. You get this idea. So there's typically now sociologists believe that there's 3 degrees of influence, right? Where it's friends of friends of friends, and what they do affects you. And if it affects you in the way that you play, the way you work, the way you interact, the way you buy and shop for goods and services in the real world, then those are patterns that we think can best be understood and predicted using this idea of a knowledge graph and reasoning on it. So these are the technologies that we're excited about. And at Foursquare, we have access to 16 billion such movement data points, right, or that we have collected, visits to over 200 million places or public points of interest that we've collected over the lifetime of the company. And this is such a rich treasure trove of data from which to build this knowledge graph. And so we're excited about bringing this out and making it accessible, again, through those visualization and conversational interfaces to our customers, so that they can make intelligent decisions like site selection that Kumar mentioned, like placement of, whether it's telco or companies that are rolling out their broadband services and want to look for neighborhoods where this could be well received, or retail, where obviously they're trying to establish new stores in this post-pandemic world, or real estate, where you're looking to assess the value of a property based on its relationship to other properties in the neighborhood. All of these are exceptionally suitable use cases for the knowledge graph and geospatial data. So we're really excited about it.
Yeah, I think I'll add briefly. Vin did a really good job of like covering why it's important to think graph when you think of geospatial data. From a machine learning standpoint, when you want to do geospatial inference, you can't serve the whole surface of the earth as an input, right? So you have, even for humans, we have access to a lot of information, but we focus and we bring the relevant information to the task, the reasoning task, or the decision task. And you have to do the same thing for machine learning. Now, geospatial or spatial data has the advantage of being, in physics, I would call it low pass. Things that are near each other tend to impact things that happen more so than things that are far away. Now, distance is a simple, dumb way to think about geospatial or spatial, but there's more intelligent ways of, when you think about a graph representation, the distance between two things, the semantic distance, would be captured via an edge between the two entities. So when you think of it that way, now you might say, oh, well, London and New York are quite far away, but if you're deciding where should you, what's the flight you have to take, the decision there is one flight, one hop, and whether you go from San Diego to New York, or New York to London, or even San Diego to LA, they're all distance unit one, right? In terms of reasoning, the impact of what's happening in one location versus the other would be equivalent. Like a flight getting delayed at one of those airports could result in the estimated arrival times, which let's say a machine learning system is predicting, would be impacted. So how do you bring that type of information in an efficient way? Graph databases are the best way to do it. I mean, you can always do hashing and other tricks, but intrinsically, not just having geospatial data, but organizing it in a way that you can efficiently generate whatever is relevant to the machine learning model for reasoning, that becomes important. That allows you to do like real-time or interactive analytics, and a lot happens when you design services under the hood. Picking the right data structure, picking the right representation is important for applications that are working with geospatial data. Pam, you're on mute. I'm not able to hear you.
Apologies.
Okay, you're back.
Yeah, coming live from New York, you hear fire trucks, so didn't want that to interrupt us. But another trend we're watching is privacy first innovation. I know we've been watching it closely here at Foursquare, Vin. Can you tell us more about how technology is advancing to keep up with the changing privacy and compliance landscape?
Yeah, I think it's really important to first acknowledge that we see at Foursquare a person's, an individual's location as personal information, right? So, and we treat it with the same respect and regard. And so in order to do that, we have a number of policies, processes, and auditable mechanisms with which we can make sure that the individual privacy is protected and preserved, even as we aggregate and analyze this data in large quantities to extract patterns that aren't revealing the individual's identity and uncompromising that privacy, right? So if we kind of start with that notion, the premise really is that regulations are increasingly specifying the need to require explicit consent from individuals when we collect data from them, as we do at Foursquare with the apps that we build and provide location-based services to our customers. And even with that, in addition to it, as you look at being able to transform the data and aggregate it and analyze it, there are a number of new techniques specifically to handle the privacy of location information. And if you kind of think of it as two ways, one is where there's obvious, explicit, private information that you could suppress, you could remove. If this were a social security number, you would just delete it or mask it, or you would obfuscate it so it never shows up downstream in any of the applications. But if you imagine that a person's particular location coordinates could leave a trace and you could retrace that path and identify, then these are things that can be protected and prevented with mechanisms like clean room technologies, like differential privacy and homomorphic encryption, just to kind of name 3 very dense technical terms. But the premise really here is that when we want to allow, if you imagine, it's a little bit like, let's say we wanted to find a particular a SNP of the DNA that predicts the likelihood of cancer in a very small population of people. You need to be able to collect DNA. Researchers need to be able to work with the individual DNA samples that they collect without disclosing the identity of the individuals, and then be able to, in some cases, share across hospitals the DNA records and then run analytic algorithms across them, and to do that without sharing the data itself with each other. So if you imagine the same thing with, say, individual location data, a clean room is this secure, multi-party computational environment where different parties can each bring their data sets without sharing it or disclosing it with others. But the model or the analytic process can execute or run with this shared data. And so you can start to find patterns. You can detect that particular SNP of the DNA that has the likelihood of causing cancer, of that particular kind of cancer, or look for a particular pattern of movement in aggregate across this population of people that helps you do that. So we think clean rooms, particularly now with a lot of these capabilities being available on AWS as a service, we can take advantage of. This makes it relatively easy for Foursquare and its partners and customers to bring this combination of data sets together and to do that in a privacy preserving way. The second, more in-depth technical capability that we're building into our processes and our mechanisms is the idea that we want to be able to prevent queries. And I talked about how, querying data sets is going to become so much more easier for so many more people. But when you do that, and if you did it in such a way that you asked a very specific question about a group of people, and then you had just one additional person in that data set, and you ask the same question, you might be able to infer the identity of that one individual that you added to the data set between those 2 queries. And so what we're trying to do with differential privacy is preserve the privacy of that difference, of that individual that you just added, by making sure that there's a privacy budget to every question or query that you ask the data set, and that there's a certain amount of noise baked into the system so no one person's identity could be inferred or extracted from a sequence of queries. And so we think that this is a very powerful, and it has algorithmic guarantees for privacy. So we're pretty excited about this set of technologies that we can bring to bear on location data. And then finally, there's the whole change in operations, right? So being able to just add and subtract, but over time, if you do lots of interesting complex algorithms, being able to keep the data encrypted even as you perform these operations on them becomes really, really important. And there's again mathematical techniques to make sure that the form of the input and the output are preserved even as these operations happen on them during encryption. And that's what homomorphic encryption refers to. And it gets very complicated very quickly, and it gets computationally expensive very quickly. But we do think that this is a powerful technology that we can take advantage of going forward to help preserve the privacy of individuals.
Kumar, any inputs?
Yeah, I think from the Amazon Web Services side, we take security, privacy, and compliance as our #1 tenet. Between that and service availability, even though I work in machine learning and AI and cutting edge technologies, that's our badge of honor. I think being able to keep all of our customers rely on us providing world-class security, and also ensuring that the data that they're working with has the necessary services support for ensuring privacy and compliance. So for example, things like HIPAA compliance, SOC compliance, a lot of our services just out of the box offer those. So if customers who are trying to build applications that require those can leverage that. The differential privacy, and I mean, when you look at nowadays, user content or user data is a large part of our customers' like approach to building better personalized services or even better machine learning and AI technologies. And it is a lot, we hear from a lot of our customers about how do I ensure data lineage? How do I empower my users or our customers' users to be able to take control of the data that they have? How do we also ensure that whether they be traditional calculations or computations or new machine learning and AI systems, when they operate on these data sets, that's a combination of publicly available data and personal data or privacy data. How do you make sure that things like differential privacy and you only use the information you need to the degree, and also have clear-cut mechanisms for the users to control it. Like if you don't want your data to be used anymore, you're no longer a member of a subscription service for one of our customer services, the customers would like to know, how can I quickly eliminate that data from my machine learning models, from my infrastructure, from my systems. So AWS services today offer some capabilities, like Data Zone is a new service we offered, or we launched at reInvent last year, which allows customers to clearly track which data is coming from which sources, and how to take control of that when you build your applications or machine learning and AI systems. So I think the fundamentals of differential privacy are very powerful. How do you make sure that you get the same answer, whether you add or subtract an individual? That way you know that that individual's data, the contribution is limited in the way, and that preserves the privacy of that one individual. In geospatial, it has implications. The nice thing about geospatial is that the answer is expected to be somewhat smooth about a certain region, or if you talk about a certain zip code, or as long as if you want to do things in a privacy preserving way, you can always zoom out to a certain level of resolution, geospatial resolution, where you preserve the privacy, because the information you're going to get in terms of insights is no longer affected by one or a few individuals. And by design, you can't reverse engineer anything but one or a few small subset of individuals. I actually think, switching to machine learning, you want your machine learning systems to be robust, right? You want them to give you insights. You don't want them to act like lookup tables that look up a single person's information. I actually think the way to build more robust machine learning systems and AI systems is to actually do it in a privacy preserving way. Then whatever you find are intrinsically robust, and not, in my view, if you add or remove a sample from your training data set and all of a sudden your model behaves differently, there's something wrong with your model, and not to mention that you're not doing things in a privacy preserving way. So I think not only for the privacy reasons, but also in order to build robust machine learning algorithms and systems that actually do provide insights that are valid, doing them together is the best way to do it. And AWS has many capabilities. If you're building services, you can look up Data Zone, you can look at security compliance and privacy features in both machine learning and AI services, and also traditional AWS services for how to best leverage that.
Great, thanks, Kumar. Being conscious of time here, in the final few minutes that we have here, any final thoughts that either of you want to leave us with? Very curious to know what both of you think the future holds long term.
So I think one of the things, at least for me personally, is that I'm pretty excited about the collaboration with Foursquare and bringing these types of location technologies into SageMaker and making it available for all of our SageMaker customers. Notebooks have really helped a lot. So I'm really looking forward to things that'll help data scientists or machine learning engineers, or even non-ML AI folks that are working with geospatial data, become more efficient and become more productive. I think that's definitely one aspect. The flip side also, I think the ability to work together with an AI system that accelerates you is pretty exciting. The amount of geospatial data, the information about the Earth is getting better and better. Like when I look at just the number of satellites or the number of number of sensors that we have at the edge that are sensing things about the Earth, whether it be about greenhouse emissions, whether it be about satellite imagery to help with real-time events monitoring and reacting in real time to those. I see a world where we're going to become more and more rich in terms of being able to both understand the world and bring that to your applications and to reacting to events and helping humans perform better. But in general, like if I look back 5 or 10 years from now, one transformation that I expect this decade is moving from just understanding what from an ML/AI system to when and where just as effectively. Today, if you look at any system, it's almost obvious that it can do vision, it can do language. And the what is solved. Like, what is the article about? What is in the picture? What is in the video? Content classification is pretty well solved. But getting to where did it happen? When did it happen? And also being able to integrate intuitively into these systems. Humans are very spatially aware. Humans are also temporally aware. So I think AI systems, ML systems will bring a lot more of their reasoning to when did it happen, where did it happen, and how does that relate to what happened. I think location intelligence will become a key part of almost every application that'll be built. So pretty excited about that.
So Pam, I'm going to be the disruptive contrarian problem child in your classroom and I'll answer the exact opposite question, not what we expect to see in the long term, but to our listeners and currently and in the future, what they can do today. And so what you can do today, just right away after this webinar ends, is to build a robust and powerful machine learning model. Start with good data. Because garbage data just produces garbage models. So the best data that you can start with for location comes from Foursquare. We've spent years making sure that it's corrected and curated and collected the right way, and we deliver it in any form that you like through the Amazon Data Exchange, so it's really easy to consume. So build your geospatial applications if you're a data developer or a application developer with the SDK tools that we provide and the data sets that we have to offer. If you're a data scientist, train your models with the data that we have that we can surface in through the AWS services. And then if you are a data scientist, there's no better tool on AWS than SageMaker to bring all of these components together. So you can start with the data that we have from Foursquare, use the SageMaker geospatial capabilities, render, visualize this in Studio, in SageMaker, but then start to explore the data, build your hypothesis, test it, build a model, experiment with it, and it makes it really, really simple to train, build, train, and deploy models in SageMaker on AWS. And so with that, you start to get to work with this full richness of geospatial data, build models that can help you solve business problems. So if you're a line of business owner, a CMO, a CEO, CIO, you should be looking at how can you take advantage of geospatial data to make these decisions, because that's where the differentiation will come through in the long run. Because as more and more ML models become commodities and more data becomes readily available to just about everybody, the edge comes from the type of data that you don't use today. And enterprises have access to geospatial data, but they don't use it effectively enough. And if you have the tools for this, as we're now building with AWS, with Kumar's team in mind, I think it'll become so much more powerful for you to take advantage of those and get that differentiation for your own products and services.
Awesome, thanks, Vin. And thank you for being a disruptive student, because I think you gave our audience some actionable next steps. Get out there and start exploring and building. Well, that wraps up our time today. I want to thank Kumar and Vin for spending the last hour with us. It's been great, and thank you, everyone. Thanks for joining.
Thank you all. Thanks, Pam. Thanks,
Bye.
Kumar.